This video will be on conservative vector fields and how to determine if a two-dimensional vector field is conservative. So a conservative vector field is one in which the line integral over it is independent upon the path it takes. So let's say we've got this squiggly path, right? The thought of trying to do the line integral over this curve makes me sad. But if the vector field we are integrating over happens to be conservative, we can just take the starting point and the ending point and just pick any curve we want. So if this is conservative, instead of doing this squiggly path, we can just do this straight line curve, which is a lot easier to integrate over. There is a relatively simple test to determine whether a two-dimensional vector field is in fact conservative. So that test is you take the function in the x-coordinate and you take the partial derivative with respect to y, right? Then you take the function in the y-coordinate and you take the partial derivative with respect to x. I'm going to go through a couple of examples of doing this just to give you a feel for it. Here we have an example of another vector field. So here we have a vector field. F is this is just a vector field that points radially outward from the origin with a magnitude of 1. So if we take the derivative of the portion of this vector field that is in the x-coordinate with respect to y, right? So we have x over all that stuff with respect to y. We end up with, so I pulled the x out because we're treating that as a constant. This is x squared plus y squared to the negative 1/2. So I pull the negative 1/2 out, I subtract by 1, I get 3 over 2. Then times the derivative of the inside, which is 2y. Rearrange all this, the 2 times 1/2 is 1. Pull the negative out, we get xy times that. So now we have to take the derivative of the portion in the y coordinate with respect to x. So we have y over this stuff, right, with respect to x. We can pull the y out because we're treating that as a constant. The derivative of the outside, we pull the 1/2 from this out to the front, the negative 1/2. Then we subtract 1 from it, we get 3 over 2. Take the derivative of the inside. This is 0 because we're taking it with respect to x. The derivative of the x squared gives you 2x. 2 times 1/2 is 1. Pull the negative out, combine the y and the x, and you end up with this. So if you notice that when you take this derivative and this derivative, you end up with the same value. So this is a conservative vector field because these two values are equal to each other. Yeah. So here's another example. You just have, this is your vector field. You take the derivative with respect to y of this part. You take the derivative with respect to y. This part, you take the derivative with respect to x. So here, over here, we get 2y, right? And that's what I have down there. And over here, you get 2x, which is what I have down here. 2y and 2x is not the same thing, so this is not a conservative vector field. Here's an example where it's up here, we had x squared plus y squared, x squared plus y squared. Down here, we just have x plus y and x plus y. The derivative of x plus y with respect to y is just 1. The derivative of x plus y with respect to x is just 1. 1 is the same as 1, so this is conservative. Here is one that's just xy. If you take the derivative of x with respect to y, you get 0. If you take the derivative of y with respect to x, you get 0. So this is conservative. Notice you're just taking the first one, so you're just crisscrossing the variables. So you just take the derivative of the first part with respect to y, the derivative of the second part with respect to x, see if they're equal. If they are, good. It's conservative. If not, then it's not conservative, and you can't use any of the nice properties that come with that. So this is just another example. Our vector field here is x sine of y, and then 1/2 x squared cosine of y. So if we take the derivative of the function in the x coordinate with respect to y, we get, treat that as a constant, sine of y is cosine of y, we get x cosine of y. If we take the derivative of the function in the y coordinate with respect to x, we get x, we treat this as a constant, so this just carries down. The derivative of x squared, we pull the 2 out, 2 times 1/2 is 1, we get x cosine of y. So if you notice, this derivative and this derivative are the same value, so this is a conservative vector field as well.